Hi everyone, welcome to this chemistry class where we are going to learn how to balance chemical equations. Balancing equations is a very important thing which we must know and master, and I'm going to make it really easy for you. I'm going to show you the different techniques on how to balance and which one I would recommend, because always this confusion is there, which technique should I use, which one is the fastest, if I get stuck, which one should I switch to. I'll answer all of that, and I hope you'll be able to balance equations very easily after this class. So keep your pen and paper ready because very practical class. Let's get into balancing together. Now before we begin, I just want to say do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and do share it with your friends. For the ICSE students, we have physics, chemistry, biology and maths courses for classes 8, 9 and 10. Once again, do share out our courses with your friends. And if you want to learn coding, we have Python programming, we have Java coding, and we have physics and chemistry for the Cambridge IGCSE, which is the international board. So please do share our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected with Manocha Academy and keep learning. So when we are talking about balancing equations, the first question is, why do we balance chemical equations? So we are going to look at that, and then the goal for this class is we are going to see the different methods. We are going to be learning the table method, the hit and trial method, and this wonderful ABCD method which can help us solve even difficult equations that we are not able to balance. So I'm going to try to cover all these methods in today's class and make it really easy for you. So let's get started. So I'm sure all of you have seen this beam balance. Like if you go for vegetable shopping, of course nowadays they're replaced with this electronic balance where it just gives us the weight, but this is the traditional beam balance, or we call it as tarazu in Hindi. So where if you place the apples over here, and let's say we place some masses over here, and let's say when we put these 1 kg weights or masses, we see that it gets balanced. So then what is the weight of these apples? Or correctly speaking, physics, the mass of these apples is 1 kg because it is now balanced. Similarly, we are going to be balancing masses in chemical equations or the number of atoms. So for example, let's discuss this balancing. Let's really understand what are we trying to balance and why. So this is the famous equation all of you have seen. Hydrogen plus oxygen is water, and this we call the word equation because we have written it in simple words. But really we are chemistry guys, so we want to translate it into a chemical equation by changing all the words into symbols. Now how do we do that? Hydrogen, why have I written H2? Why have I not just written H? Because remember, this thing is a word equation and we are changing it into a chemical equation here. But why do we see this H2, O2? Why don't just simple H and O? Because remember, the world exists in terms of molecules, or substances exist in terms of molecules, because molecules can exist independently, right? They're stable. So that is why, remember, chemical equations are written in terms of molecules. So what is one molecule of hydrogen? H2, because hydrogen is diatomic gas. If you're just writing the atom of oxygen, of hydrogen, you would have written H. But molecule is H2. Similarly, molecule of oxygen, O2, containing 2 atoms of oxygen. And when these two react together, they form the compound water, H2O. So for elements, remember, we use atomicity. These guys are diatomic, these are elements. For molecules, we have to use valency, right? That's why H2O here. So this is our chemical equation. Now if we take a look, what does this mean according to our beam balance? So if we want to put these, what do we call the guys on the left as in the chemical equation? These are called as our reactants, and this side is called the products. So let's take these reactants here and put it on the left side of the beam balance, and the products we'll put it on the right side. Okay. So for example, if you have got H2 and O2 here, and here we have H2O. So since we have put it on a beam balance, means we are going to try to see if their masses are balancing or not. So can you guys tell me what is the mass of H2? Or let's start with what is the mass of one hydrogen atom? You guys know that? mass of hydrogen atom is 1 AMU or 1 U, whichever way you guys write it, right? It's the lightest atom. Oxygen is 16 U. Okay. So if we work out the numbers, what is the mass of hydrogen over here? Hydrogen is basically 2 times 1. So this is going to be 2U, plus we have 16U times 2, so 32U. So what is the total here? Total is basically 34U or 34 AMU. You guys agree? What do we have on the product side? Water. Water, what will be the mass? This is going to be 2U plus 16U. That gives me 18U. So if we take the chemical equation if we wrote and we just put it on our beam balance, will it balance? You have 34U here and 18U here. So definitely it's going to tilt towards the left hand side. Do you guys agree? So our beam balance is definitely going to swing this way. It is not a balanced equation. And in life, everybody wants balance, right? You keep hearing this term, lead a balanced life. Everything we want perfect balance. Same here. This is not good. And what is not good here? How can 34 AMU become 18 AMU? That means there is a loss in mass. Can a loss in mass happen in a chemical reaction? We know there is law of conservation of mass. Mass cannot simply appear or disappear. So this is against the law of conservation of mass. So that is what we are trying to satisfy here. That we are trying to balance because we want to satisfy the law of conservation of mass. So we'll behave like the vegetable guy. We'll say, okay, there's more mass there, less here. I'm going to put more here. What can I put? I can only put products. I can put hydrogen, oxygen here. I can only put water. So let's say if we put 2 water here. So 2 water means it's going to become 2 times 18. That means if I put 2 water here, this new mass is going to be 2 times 18, which is 36U. Now we'll again be the vegetable guy, the fruit guy will say, oh, there's 36U too much over here, only 34U. So it's still not balanced. What will we do here now? It's still not balanced, so we'll say, okay, we are a smart vegetable guy, so we'll say to balance it, let's put 2 hydrogen. Because when we put 2 hydrogen, this number is going to change to 4U, because 2 times 1, so that's 4U. So 4U plus 32U, 36U. So like the fruit seller, we are now happy because our thing is balanced. 36 AMU here, 36 AMU here. So this is the goal, is to balance the mass. The law of conservation of mass must be satisfied. Famous question, why are we balancing equation? To satisfy law of conservation of mass. But do we every time need to look at all these masses and do that? The good news is, thankfully, no. So what you really need to balance is the number of atoms of each element. Because if you carefully notice, hydrogen is still remaining hydrogen, oxygen is still there in the products. It's not that oxygen has become nitrogen or something else. So instead of balancing masses, we can simply balance the number of atoms of each and every element. So if you look at our final equation here, even though we tried to balance mass, what have we ended up doing? How many hydrogen atoms on the left? You can see there is 4 hydrogen atoms here. How many oxygen atoms? 2 oxygen or 2O. This is not 20. How many do we have in the products? 2 hydrogen atoms in water, but there are 2 molecules of water. So 4 hydrogen here. And once again, 2 oxygen because 1 water molecule has 1 oxygen atom multiplied by 2. So this is very important, that what we are really balancing is the number of atoms of each element here. Now the important question is, how do we balance a chemical equation? Because as I said, we don't have to do a mass every time, we just have to focus on the number of atoms of each element. So there are many methods. One is the basic table method, then there is hit and trial, then there is the ABCD, powerful ABCD method. And I'm going to go through all of these in today's class and we'll see which one we should use. What is the recommendation here? Of course, yours might be different, but let's see what is the best way we can do, because we want to solve it quick and accurately. And of course, balancing chemical equations is like solving the Rubik's Cube. Have you guys played Rubik's Cube? It's really fun and interesting, but I always forget the method. It's really requires a lot of patience and practice, but it's very fun to solve because it's a little hard, right? Same with balancing equations, that it requires patience and practice. And trust me, if you do it, don't memorize the balancing, keep practicing, you'll become an expert at it. So first we'll start with the table method. So what does the table method say? Simply make a table of the number of atoms of each element. So this is like you're doing accounting, right? You're checking, okay, how many atoms of each element, and our goal is to balance it. So the table gives you a very nice, easy visualization, as we'll see. And then you start by balancing the easiest elements and keep doing it till the table is balanced. So let's try it out. So for example, we'll again take our simple example. Hydrogen plus oxygen gives us water. And everybody, please make this table right now. What is your table? There are going to be 3 columns in it. Elements, left hand side, right hand side. These are going to be the counts of the atoms. So can you guys tell me what are the elements involved in this reaction? What are the elements here? Clearly you can see the elements are hydrogen and oxygen. So let's put that in the table. Hydrogen and oxygen. You can put whichever one. Since hydrogen comes first, I put hydrogen and then oxygen. LHS, RHS means what we are putting down here is number of atoms of the element. Okay, so we'll be putting down the number of atoms of each element. On the LHS means left hand side, RHS is right hand side. So on the left hand side, how many hydrogen atoms are you seeing here? Can you tell me? Very good, the right answer is 2, because there are 2 atoms of hydrogen, 1 molecule containing 2 atoms. So let's put that down. How many oxygen atoms on the left? Again 2 atoms. How many hydrogen atoms on the right side? H2O is containing 2 atoms of hydrogen. So I'm going to put that here, 2. How many oxygen atoms? Water molecule has only 1 oxygen atom, 1. Very good. So everybody please make that table, and you can see it's a nice easy visualization. So you have made the table. Now the goal is, if something is balanced, like hydrogen, you can see 2 and 2, it's already balanced, so we don't have to worry about it. So start by balancing the unbalanced element. And if there are multiple of them, do the easiest one first. Okay. So here there is oxygen, so we have to do that. Oxygen you can see is 2 on the left, 1 on the right. So obviously we have to increase on the right. Now how do we increase? Can we simply change this formula? Can we do H2O2? This is no longer water, this is hydrogen peroxide. So this is a crime in chemistry. You have committed a crime by changing formulas. That is not allowed. So remember, all you are allowed to do is just do multiplications. Means you, just like a fruit seller adds apples or adds weights, right? Same way you can just put multiples. So you can put multipliers in front of these. That's all you can do. Okay. So that's all you are allowed to do. So how do I, clearly I want to increase on the right hand side. So left hand side is 2, right hand side, if I want to increase, let me multiply by 2. Now some of you might say, why didn't I multiply by 3, 4 or 5? Why do you want to be so generous? Just that much which is needed. So be frugal, don't be generous. Okay. So we have multiplied by 2 here. So what will happen? Oxygen will become 2. But we have affected hydrogen, because how many hydrogen atoms now? 2 times 2, 4. So cut it, cancel it like this. You can use an eraser or you can simply cut it and show your working. This is 4. So see, oxygen row is now balanced. That means we don't have to worry about oxygen. But hydrogen is clearly unbalanced. Hydrogen is clearly unbalanced here. Yes. So what are we going to do? Because hydrogen is unbalanced, we are going to multiply, because it's more on the right, less on the left. So the multiplier should be on the left. So let's multiply by 2 here to balance it. Always your goal should be to balance it. If you multiply by 3, it will become 6 and 4. So now you can see hydrogen has also become 4. So that's what, keep doing till the table is balanced. Table balance means each and every row should be balanced. As you can see, hydrogen is 4, 4, perfectly balanced. Oxygen 2, 2, it's balanced. Is that clear? So this is how you balance these kind of equations, by making sure that each and every row the number is matching. So there we can see our equation is balanced. So this is called the table method. It's a very simple method. Make this table, keep cutting, making sure each and every row gets balanced, and then you get it. Let's practice table method with this one. So come on everybody, write down this equation, and you can check with the table. If it's balanced, then you don't have to do anything. So this table helps you account for all the numbers. So let's try it out. So what are the elements over here? This time we have iron, and please don't put water here, because water is a compound. You need to break it into hydrogen and oxygen. This is the table of elements. Okay. So yes, it's simple. Let's practice the table method. Now for each element, for iron, how many left hand side, how many atoms of iron? 1 atom. So let's put 1. How many atoms of iron on the right? 3. Let's put 3. How many hydrogen atoms on the left side? 2. We can put 2 here. How many hydrogen on the right? 2. We'll put 2. Oxygen 1 on the left. On the right, 4. So there is our table. Do you guys agree with this? Now what is the goal of what did the table method say? Start by balancing the easiest element. So whichever you find easy. So you can say hydrogen is already balanced. I need to change either iron or oxygen, whichever one you want to do. Okay. So let's say we find iron easy. So let's go ahead and change that. So it should be simple. We'll simply multiply by 3 here, and iron becomes balanced. Iron is done. Now oxygen is 4 here. So clearly on the left hand side we have to add a multiplier. So let's put the multiplier here, 4. So oxygen is clearly balanced on the left now. But see, we have affected the other element. Don't stop here, because you have put a 4 in front of hydrogen. How many hydrogen now? 4 times 2, 8. Is that clear? So don't worry, you have spoiled the balancing, but we can always adjust it on the other side. So hydrogen is 8 here, only 2 there. So how do we balance it? We will put a multiplier here of 4. There you go. 3, 3, 8, 8, 4, 4. Table done. And this is our final answer. Let's practice another one with the table method. So here we have this lead nitrate. When you heat it, it breaks into lead oxide, nitrogen dioxide, oxygen. So come on, all of you make this table. What element should I put in here? So always start from the equation. If you start from the left, there is lead. So let's put lead first. Nitrate is not an element, it's an ion. It contains nitrogen and oxygen. Remember, nitrate is a polyatomic ion containing nitrogen and oxygen. So please put that. Okay. Now number of atoms. How many lead atoms on the left? This is Pb1 or Pb, right? So 1 lead atom. How many on the right? 1. How many nitrogen on the left? NO3 has only 1 nitrogen, but there is a whole bracket 2. That means there are 2 nitrates. So 2 times 1. Be careful of the counting. If the counting is wrong, gone. So 2 nitrogen on the left. How many on the right? Only 1 nitrogen on the right. How many oxygen on the left? 3 oxygen in nitrate multiplied by 2, because there are 2 nitrates. So 6. Please don't do 3 plus 2. 3 times 2, 6. How many oxygen on the right hand side? 1 plus 2 plus 2. You have to add up all. If the element is present in multiple compounds, you have to, or substances, you have to add it up. So 1 plus 2 plus 2, 5. So there's our table. Always check if everything is balanced in the table, then great news. You don't have to do anything. But clearly you can see only lead is balanced. These 2 guys are not balanced. Which element is easier to balance here? Clearly nitrogen looks easier to balance because oxygen is all over the place. So let's finish off nitrogen. Nitrogen only 2 on the left, 1 on the right. So we are going to multiply here by 2. So we get a 2 nitrogen here. But how many oxygen? See, you have affected oxygen. So don't forget that 2 times 2, 4, 5, 6, 7. Oh, there's 6 there, 7 there. So oxygen still remains unfortunately unbalanced, right? because this is 1, 1, 2, 2, but 6 and 7. Don't worry, don't get scared. It's more on the right, less on the left. Can you guys see that? So where should I increase? Since it's more on the right, less on the left, we will increase the the oxygen on the left. How do I increase? Only multipliers, right? So what we need to do? Multiply again with the smallest number. Don't be too generous. Be generous in life, but not with equations. So 6 and 7. So let's multiply this entire thing. We have no option but to multiply this entire reactant by 2. You guys agree? So this entire table will multiply by 2. All the elements we have multiplied by 2. So 6 becomes 12, 2 becomes 4, 1 becomes 2. So looks like we have disturbed the whole table. But don't worry. We'll again go and balance each element, which is, again we'll start with the easy ones. So lead is 2 here, only 1 there. So first let's finish off lead. So 2 times lead here, that should take care of 2 lead, and oxygen is now 2 plus 4, which is 6, 7, 8. Nitrogen 4 here, only 2 there. So let's multiply this nitrogen by 4 now to balance nitrogen. So nitrogen has got balanced. How much oxygen do we have now on the right? 2 plus 4 times 2, 8. So 8 plus 2, 10 plus 2, 12. And the good news, can you see? Oxygen 12, oxygen 12. So even though we started with the easy, we did the easy ones first, the difficult one automatically got balanced here. So this is the nice thing about table method. Do it one element at a time. If you multiply, you might be disturbing the others. Don't worry. It's just like, you're keeping your statistics or numbers here, and finally check that each and every row will get balanced. So we have done the table method. Now let's look at the hit and trial method. So in hit and trial method is more like, trying it out, right? Trying different numbers and trying to balance without drawing the table. So the nice thing is it is quick and easy, and you can start by once again balancing the easiest ones. Just like, when you have to study for an exam or do the syllabus, we always try to finish the easy chapters first so that our confidence gets boosted. Same thing with balancing equations. Finish balancing the easy one first, because sometimes automatically the difficult ones get balanced. So do the easiest elements first and keep doing it till the equation gets balanced. And I'll teach you another nice technique where you can try fractions also. So we said we are multiplying. Usually we multiply with, natural numbers or normal integers, but you can even multiply sometimes with fractions. I'll show you those tricks. Okay. So let's say we want to balance this equation. Sodium plus chlorine gives sodium chloride. See again, sodium is monoatomic, it's a metal. Chlorine diatomic, written as Cl2, and sodium chloride compound valency 1, 1, so NaCl. Okay. So this is our equation. If I want to balance it, I could draw the table, but table you saw is a little lengthy, right? You have to write all this stuff. If they ask you to show the table, then please do it. But if you directly try to do it mentally, hit and trial means try to do it mentally and just putting the numbers as you go. So what is happening here? You can see sodium is already balanced. 1 sodium here, 1 here. Chlorine is the guy which is problem, right? 2 chlorine, 1 chlorine. So chlorine is less on the right hand side. So put a multiplier of 2 here. So can you see chlorine has been balanced? 2 chlorine, 2 chlorine. But now you have made it 2 sodium. So simply put a 2 here. And you will be done. That's it. So that's all the hit and trial method. But since you don't have the nice table, please do a double check. 2 sodium, 2 sodium. 2 chlorine, 2 times 1 chlorine, 2. Done. Do you guys want to try this one with the hit and trial method? Come on, try this. So you can see potassium already balanced, chlorine already balanced, oxygen is 3, but oxygen is 2 here. So always ask yourself the question, where is oxygen less? It's less here, it is more here. So I want to multiply. So let's say if we multiply by 2. So how much have we got? 4 here, but 3 here. So now it is less here. So like the fruit and vegetable guy, we'll put a 2 here. So how much does it become? It will become a 6 on that side. So oxygen becomes 6. Here it is only 4. So we have to put a 3 here. But by multiplying by 2, we have disturbed potassium and chlorine. So there's 2 potassium, 2 chlorine, only 1 here. So we put a 2 and there you can see it's balanced. So hit and trial is just putting the numbers, keep on trying till you get the combination without making the table. So you're basically doing it mentally. And I would recommend it because once you're familiar with the table method, you can upgrade yourself to hit and trial because it is way faster and the simple equations you can do it quickly. Now do you guys want to see an awesome fractions trick? How we can do this equation with fractions? Do you want to try it out? So please write down this equation one more time. So let's write it again. KClO3 gives KCl plus oxygen. So we can see potassium was balanced, chlorine was balanced, only oxygen is causing the problem. So when you have one guy left and that guy exists in element form, means alone, then you can easily balance it using maths fractions. What do I mean by that? You can see here, we have 3 oxygens and we have 2 oxygens here. So by what number, since it's less over here, by what number should I multiply this to get 3 oxygens? Can you tell me? By what number should I multiply O2 to get 3 oxygen? If you're allowed to think in terms of fraction, you'll say, why don't I multiply by 3 by 2? Because after all, 3 by 2 times 2 is 3. 1.5 or 3 by 2? Yes. Here you can think about improper fractions. You don't have to write 1.5. So you write 3 by 2. So now will you guys agree with me? Is this equation balanced? Please take a look, all of you. Because after doing this multiplication, you can see there's 3 oxygen and 3 by 2 times 2, which means again 3 oxygen here. So great, we are done. But are we allowed to leave fractions? No. So the chemistry teachers will get really angry if you leave the final answer as having fractions. So what do you need to do? Get rid of the fraction. How do you get rid of the fraction? Because the problem is there's a denominator. How do you get rid of the denominator? By multiplying out so that the denominator gets cancelled. So denominator is 2. So you multiply this entire equation by 2. So if you multiply this entire equation by 2, you're going to get what? 2 KClO3 is going to give you 2 KCl and 3 by 2 times 2. So 2 and 2 will cancel plus 3 oxygen. There you go. We have the answer. So you can see that whichever way you like, sometimes fractions are way faster because you can see 3 by 2 it's solved. So I just multiply by 2 and you can see we have got exactly the same answer. Done. So this fractions method is a little more advanced method. The first method was simple where we were doing hit and trial. In this last method, why did we use fraction? Because we saw KCl is already balanced. Oxygen is 3 here, it's 2 here. So if I multiply oxygen atoms by 3 by 2, what is 3 by 2 times 2? 2 will cancel. So 3 oxygen over here, 3 over here. We have balanced it. But the only problem is we cannot leave fractions in our final answer. So how do we get rid of the denominator of the fraction? Just multiply the whole thing by 2. So if you multiply the entire equation by 2, 2 KClO3, 2 KCl and 2 times 3 by 2, the 2 will cancel. So 3O2, that is the same as our first answer. Clear? So you guys go ahead and try this. You can try, again, try with hit and trial. You can try it with fractions or without fractions. I don't know. Whatever works best for you, please try this equation, all of you. So how do you do this by hit and trial method? Once again, just scan through. You can see there's 4 carbon, only 1 carbon. So let me finish the carbon 4 times, right? You can see hydrogen is 10 here, only 2 here. What if I multiply it by 5? So can all of you see carbon and hydrogen is done? 4 carbon, 4 carbon. 10 hydrogen, 5 times 2, 10 hydrogen. Done. But oxygen, how many do we have? We have 2 oxygen here. So you can see that there is 2 oxygen atoms. And how many on the right side? Count carefully. 4 times 2, 8. Plus 5 of the water, right? 5 times 1. So 4 times 2, 8 plus 5. we have 13 oxygen on the right, 8 plus 5. Yes, 4 times 2, 8, but not 1, 5 times 1 because there are 5 water, right? Each water having 1 oxygen. You understanding? It's a multiplier. So 5 times 1, 13 oxygen. So now what do? So carbon hydrogen balanced. You can see again we have one element remaining. We have 1 oxygen remaining which is luckily in the element form. So you have 2 oxygen here and 13 here. Your goal is to get to 13, right? So how will you do that? It's almost like you can think of maths equation 2 times x equals 13. So what if I do 13 by 2? If 13 by 2 is my multiplier. So let's say I put 13 by 2 here. Would it finish it off? 13 by 2 times 2? 13 oxygen. Done. So can you see how the fractions trick can really help us here to quickly balance the equation? And of course the last step is to get rid of the fractions. So good question, why is C4H10 not written as C2H5? Because in this compound it is structured to have 4 carbons and 10 hydrogens, right? If we were forming it by crisscross, yes, sometimes we end up cancelling stuff. But great question here. Here we do not simplify because the compound is like that. Remember, it is a crime to change compound formulas. So whatever formula is given, we have to use that. So how do you guys get rid of this 2? Just multiply the whole equation by 2 because you have to check what are all the denominators. There's only one denominator here. So multiply this entire thing by 2. The entire equation. It's like in maths, right? If you multiply the entire, if you have an equation, if you multiply it on both left and right hand side, the whole equation gets balanced, right? Means you're not disturbing it if you're multiplying with the same number. So what do we get here? So we are basically going to get 2C4H10, 13 times 2, the 2 will cancel, plus 13O2 is going to give us 2 times 4, 8 carbon dioxide, and 2 times 5, 10 water. You guys can see that? So you can see there is 4 times 2, 8 carbon, 8 carbon. 2 times 8, 2 times 10, 20 hydrogen, 10 times 2, 20 hydrogen. Oxygen how much? 13 times 2, 26. Please check over here. 8 times 2, 16, plus 10 times 1. Remember H2O1. So 16 plus 10, 26. We are balanced. So the fractions can be really, really powerful and very fast if you have one element remaining like this, right? You could have also done it without fractions. You could have sat and, since you had done it till here, then you saw oxygen is less, but you are realizing that there's the odd even problem. There's 13 over here. So maybe you start multiplying the stuff, you do 6 times, and try to balance it, get it close to that. That is also possible, but fractions will be way faster. Only remember, do not leave final answer with fraction. Chemistry teacher will not like that. So please practice balancing, and I'll be doing the ABCD method in the next class. This is a more advanced method which can help you solve more difficult balancing equations. So our goal is to really balance with the easy methods, like please practice the table method first. Once you're familiar with the table method, do hit and trial method. Hit and trial is very fast. You can easily solve with that. And this is the advanced one where hit and trial, sometimes you get stuck. You are sort of in a fix that you're tried a bit of hit and trial, it's not working. Then this guy will rescue you out. But I'll teach you this in the next class because it will take a little more time. And so that I can take some doubts in this class, I'll open it up for doubts and we will continue this in the next class. But before that, please promise me to practice the first 2 methods, table method and your hit and trial method. That is your homework. This extra method I'll be teaching you next time. And one important thing when you're balancing equations, what are some important checks to do? That make sure that your number of atoms of all the elements are balanced. Like we checked last time, go back and check your answer because you have balanced it. You can easily check your answer by comparing each element, and also make sure that there are no common multipliers in the equation. What do I mean by that? If you guys look at this equation, is it balanced? It looks like it's balanced because you have 4 times 2, 8 hydrogen, 4 times 2, 8 hydrogen, 2 times 2, 4 oxygen, 4 oxygen. So both hydrogen, oxygen are balanced. But what is the problem? You have sort of overbalanced it, because you can see what are the coefficients here. So what are the multipliers? 4, 2 and 4. Do always check if they have a common factor. So after balancing, please check if there is a common factor. There is a common factor here. 4, 2 and 4, what is the common factor? If you simply divide by 2, we can see the highest common factor here is clearly 2. So if we simply divide by 2, we will get 2H2 plus O2 gives 2H2. So this will be marked correct. This will be marked wrong because you have unnecessarily, generously you have multiplied, which is not at all needed. Okay. So please make sure your multipliers do not have any common factor. And you can easily check your balancing by comparing the number of atoms of each element. So these are some very important tips to follow to make sure your balancing is perfectly right. So which method to use? Right now you practice the basic table method. Once you're familiar with that, please try and use hit and trial. It's way faster. Unless the teacher asks you to draw the table, you don't have to draw the table each time. Hit and trial is very good. ABCD is for the complicated equations, and I'll teach you that next time. And I'm reminding you to have patience and practice. Trust me, you'll get better with balancing. And do check out the other courses on our website. We have physics, chemistry, biology and maths for CBSE class 8, 9 and 10. So guys, if you haven't taken the other courses, do take them and please do share it with your friends. For the ICSE students, again we have physics, chemistry, biology and maths courses for classes 8, 9 and 10. And if you want to learn computer coding, we have Python programming, we have Java coding for you. So both of them are great languages to learn computer programming. And we have physics and chemistry for the Cambridge IGCSE, which is the international board. So do share out our courses with your friends. Make sure you have subscribed to our YouTube channel. You can also follow us on Facebook and Instagram. So stay connected with Manocha Academy, and guys, keep learning.